All right, so what we're going to do is we're going to have a look at the circle and triangle question. This one is definitely a non-calculator question, and you have to do this with a fair bit of background knowledge. So the question says a semicircle, which is this yellow bit here, is inscribed in an equilateral triangle, which is the blue triangle here, as shown below. And it says what portion of the triangle lies inside the semicircle. That says what is the area of the semicircle divided by the area of the triangle effectively. So we should hopefully know that the area of a semicircle is pi r squared over 2 because it's half of a circle, and the area of a triangle is half base times height. Now, the other thing you'll need to know is that the equilateral triangle has 60 degrees on every corner. And if you cut it in half, you have 30 on either side of those of the height here. That's the height. And we're going to label 2L as the base of the triangle. So one of these halves is L. The other thing you'll need to have is the special triangle 30-60, and you need to know that it's 1, 2, and root 3. And the other thing that's helpful is that you know that when you have a circle with the radius here, a tangent will touch, this is the tangent here. This tangent will meet the radius at a 90-degree angle. And if you have the same thing happening on the other side, then you'll have the same situation here. And these two lines have equal length. And the other thing that's also equal is the angles on either side of that middle line there. And the angles here are equal as well. All right, so those are the things you need. So if we draw in our diagram, then what you need to do is, I'll just draw it in again. We start with the semicircle, and it's easier to do the semicircle first, and then we drew the base. And then we want the triangles to have a meeting point that's reasonably even, and we're going to make sure that sits right on the edge here. Okay, and that one can go a little bit further away. Nice. Okay, so what we can do is we can label these intersection points with the fact that they are definitely the points where the tangent is meeting with the radius. And so these red lines are the radius here. Now, what you actually will find is that because this is a right angle, that means that, oh, and you also know that this angle is 60. So I'm going to put them all with the double green lines. And that means that the other angle is 30 over here. And so what's the other thing we can do? We can also label in the height. And this also is a similar triangle. So because of complementarity at this angle here, which is a right angle, then that angle that's missing is 60 degrees. Let me get rid of the highlighted yellow bits first. So that's 60 here, and that's 60 there. And that means that the other angle must be 30 degrees as well. All right, so then we can look at our two separate triangles. So the first one is the highlighted in yellow triangle, which has the length L, which I've explained is half the base, and R on it. And it's similar to the special 30-60 triangle, which has 1, 2, and root 3 on the sides there. So what that means is you can either do this using scale factors, but if we just do ratios, L divided by R is equal to, we just put the corresponding ones together. So L divided by R is 2 divided by the square root of 3, which means that L is equal to 2R over the square root of 3. So that's one relationship. The other relationship comes from a very large blue triangle here, which is composed of 60 degrees, 30 degrees, and a right angle, and that's L, and that's H. But it's similar to the 60, 30, where you have 1, 2, and the square root of 3. So once again, we can have our corresponding sides. So we have H corresponds and L. So H over L is equal to root 3 over 1. Therefore, if we multiply both sides by L, we end up with H being root 3 times L. But we know that L is 2R over the square root of 3. So we know then that H is 2R. Okay, so now we have two equations, one for L and one for H. And so we can use the triangle area formula, half times base times height. We know that the base is 2L, and we know the height is just H. So then we end up with L times H, which is L being 2R over the square root of 3, and H being 2R. So the area of the triangle is 4R squared over the square root of 3. We can choose to rationalize the denominator, so I will. So that gives me 4 root 3R squared over 3. Now the area of the semicircle is pi r squared divided by 2. That's pretty straightforward. And so then the last step is to divide the area of the semicircle by the area of the triangle. So pi r squared divided by 2 divided by 4 square root of 3 r squared over 3. Might have been easier to leave it unrationalized. Actually, yeah, maybe that's, no, never mind, it's okay. So what you do is you flip that over, becomes times, and the rest on the right reciprocates. That means I can cancel my r squareds, and I will have 3 pi over 8 square root of 3. Rationalize the denominator again, probably didn't need to do that, never mind. These will cancel, so that gives me pi times the square root of 3 over 8, which is what the required answer was. Hope that helps.